the new model of washing machine.
Good. Silence.
I kill you.
Thank you. Now we're good in time. So I'll hand it over to Max. Thank you.
I would please ask you to quickly hide because I want to do a quick photo for my Be Real. Don't know if anybody uses that, but are you hidden? Okay, very good. Nice. With that out of the way, welcome to my talk. And in the beginning, I already have to make a confession. I had to slightly rename the talk when I researched for it. So instead of how to take advantage of JS generators next features, I actually renamed it to how to take advantage of JS iterators next features, because this talk is mostly about iterators. And the second thing is, if you have any questions or if you want to ask something or throw something in, just do that. It's fine for me when I talk to just throw stuff in. Yeah, and with all of that out of the way, you can count how many times I will say the word iterator or iterating over stuff in this talk, but maybe you should. So let's start. So when I researched this talk, there's something which really grinds my gears and which I don't understand. And this goes back to actually year 6. And year 6 is this, it was this great time when ECMAScript couldn't decide if they use year numbers or if they use incremented numbers. It was like the year number was always one number before the actual number. So year 6 was 2015, and then 7 was 16, and so on. And everybody was super confused. But anyways, that's not the point. Year 6 was the ECMAScript version, which gave us one of the most notable features of JavaScript that we use from day to day now. And some of those features are array prototypes, built-in iterator prototypes, built-in destructuring promises, stuff like this. So it's like a really, really big JavaScript change. And some of these we really know very well and we use maybe daily, or it's very prevalent in our code bases. And some of these are for each map, like find, filter, includes, reduce, keys, sum, and some of the newer ones actually flat and flat map. And then there's the iterator prototype, which also got added in year 6 back then. And this prototype has the utility functions next. Yeah, that's it. That's kind of all of the utility functions you have on the iterator prototype, and there's not really much else. And it's really sad because the JavaScript iterators are baked in on a very deep level in the language, actually, even though we don't really notice them very, very much, but they're very integrated into the language. And the thing is, you can iterate over almost everything in JavaScript, which is quite funny because some use case I've never considered before actually is you can iterate over a string, right? So it will yield you all the characters of a string. And in this case, I used the spread operator because it's the easiest way to iterate over a thing or an object in JavaScript. If you use the spread operator, it tells JavaScript to use the iterator API to iterate over stuff. You can also iterate over arrays. Duh. I mean, arrays are just sequences of things, right? So like an iterator is very similar to that. So yeah, of course you can iterate over arrays. But you can also iterate over sets, for example, which is a very cool data type. And you can also iterate over maps. And it will give you the entries of this map, which is very useful in some cases if you want to have all the entries of your maps. But it's very important, per default, you cannot iterate over objects. If you try to do this, you will get an error which tells you that it can't iterate over this intermediate value. But Max, you will say, I can spread objects. It's possible. I know this. Yes, but in this, it's something different. In that case, spreading objects uses enumeration. But in this case, JavaScript is trying to iterate over the object. In this case, because we are not spreading it into another object. And objects or base objects do not have an iterator baked in. So you cannot, per default, iterate over objects. But we will come back to this. Also, you can iterate, or like one of the first where I discovered iterators is the arguments variable, which you shouldn't use, by the way. Very old stuff. But in every function, you just have your arguments in JavaScript, which is great. And that's an iterator. And many people fell over this because you cannot do array functions on the arguments variable. So that's an iterator as well. But it's also baked in on various other parts of the language. For example, promise all takes an iterable. You can pass an iterable to promise all. Same as with array from, you can pass an iterable. So if you have a generator which produces you some sequence of data or some sequence of promises, for example, you can pass that to promise all. Or you can construct an array from an iterable. Also, which is very interesting, is the map and set constructors also take an iterable. So it's possible to create or to construct maps and sets with iterables. Something which I also found very interesting is if you have an iterator, you can destructure it. And for example, if you're only interested in the first two elements of an iterator, you can just destructure it and it will just work. Something else where it was not so prevalent in my mind that we get an iterator out of this is when we use array prototype. So when we directly have an array value and we call keys or values or entries on it, we won't get an array back, which is interesting to me, but it's an iterator. And for some, this can be, you know, like a little foot gun because you cannot chain array functions to this. Yeah, and this is not to confuse with static object methods, and this is kind of a little bit of a rant, because if you use the object.values functions, or those three functions, which are not the prototype functions, but the static functions, this gives you back an array. And I was like, why, right? But anyways, going back to the prototype methods, map also has these prototype methods, which you can call. And I remember this very vividly because back then when I started using JS, you know, maps were new and everything, you know, and I wanted to try it out. And I had this case where I tried to get the keys out of my map, right? And then I wanted to map over it because I wanted to transform them. But uncount type error, map keys.map is not a function because in this case, keys is an iterator and not an array. So back then it was not possible to do this. So why is there so little support for iterators? That's actually a good question. I asked this myself. Yeah, and why didn't they implement it in the first place if they have all those great methods for array and all the other prototypes? But anyway, I forgot to introduce myself. My name is Max, by the way. I'm a software engineer, and obviously I like talking. That's why I'm here. And today we will talk about generators and iterators, or at least that's what I thought I would talk about. It's more like I will talk about iterators. But now that I have said the word iterator for like 80 times already, thanks. What even is an iterator? So let's make that clear. It's a short recap to what iterators are. And actually, it's not that hard to understand because iterators have a very simple interface or some very simple contract. And if you follow that, then JavaScript will be like, yeah, it's fine, it's an iterator. So the only thing that you have to keep in mind is that an iterator needs to have a next function, which you can call. and this next function has to give you back an object with at least the property value. And also there's this done property, which can be undefined or Boolean. And once your iterator runs out of values, so to speak, the done property has to be set to true. And if done is true, then JavaScript knows I can stop here and the iterator won't yield any more values. So, and also a very cool thing is that you can make any object in JavaScript, any object iterable, if you add this or if you implement the iterator function, and JavaScript has a very special symbol for that. And if you provide that to your object, you can make any object iterable. So if we remember this from before, where we had our foobar object, which threw us a type error, it's actually not so hard to make this iterable, because when we have this foobar object, we can just spread it into a new object and then use the symbol iterator to implement the function, which in this case, we are returning the iterator of the entries of the object. So if we would iterate over the object, we just get all the entries. So the key value pair of key and value. So if we would execute that in our console log, we would just get in one array in this case, which says foobar. So yeah, really nice. We can make any object iterable, and sometimes, you know, maybe you need this knowledge in the future, but it's possible to make any object iterable. But how can I take advantage of an iterator even? It's a good question. Iterators can be, of course, also be transformed back to arrays if you prefer working with arrays, for example, by just doing array.from iterator. But usually iterators are used when you have a big amount of values and you don't want to pull out every value at once. So to make it more pull-based, right? But in this case, if you know it's not a lot of values, you can pull out every value with this. Or you can, of course, also spread the iterator, and then you also get all the values out. And then there's this great for-off loop, with some of you also know. And JavaScript actually uses the symbol.iterator, and any object which has this implemented, you can pass into those things, right? Because everything is iterable. But of course, you can also call the function manually. So if you don't want to pull out everything at once, you can decide on your own in your code when you pull out the next value and just call the next function on it. But why am I telling you all about iterators? Well, and that's where we come to the part of my talk. There is a newly standardized TC39 proposal. Who of you does not know what TC39 is? Okay, so short recap, TC39 is just a group of people, and they try to standardize the JavaScript language. And there's like different proposals, and it's really easy to do a proposal. You just have to add a GitHub entry and then say, hey, I want to have, I don't know, this feature in JavaScript. And so to say it very simple, if you find enough people that think alike and also think that this should be a part of JavaScript, you run through some stages. And if you manage your feature to get to stage 4, this means for browser vendors and also engine creators that they now have to implement those features. So, and the proposal I'm talking about is proposal iterator help us. And this one is actually in stage 4 already. So it's being implemented by browsers and engine creators already. And if you're using TypeScript, you can already also use the functionality, because TypeScript usually, I think, implements all the features that are on stage 4. Correct me if I'm wrong. Stage 3 already? Okay. Yeah, but this is now like really, this is gonna stay. But what am I talking about? So if you remember when I showed you this slide, which was very sad before, now we get a lot of more functions. So now we have a take, we have drop, we have every, we have filter, flat map, for each, map, reduce, sum to array. which is great. Now we have so much utility on our iterators. And to me, when I saw this, I was like, I have to play with this because it's really cool. But what does that have to do with generators? You might ask, because I thought first this will be a generator talk. Well, you know, the only thing that has to do with generators is that generators return iterators. So this talk is more about iterators than generators. But anyways, I changed the title of the talk, so I should be fine. But the next slide will show us a very simple generator, and I chose this because it's very easy to understand. And this is just a generator which will run forever. We have a while true, which might look scary, but in generators this is fine because JavaScript will pause execution on the yield, and it's just a generator which will generate us all the natural numbers as long as you get a Stack Overflow. Anyway, so if we use that, if we use our naturals generator like we did before, we only had the next function. So the only thing we could do is we could pull out the next value of a generator. But now it's very nice because now we have utility functions. So when we call the naturals, so when we call the generator for our natural numbers, we get an iterator that iterates over all the natural numbers. And then we can have this map function which transforms the value. And before, this would have been very scary, or if you come from array land, this looks very scary, because in array land, you iterate or you go over all the array values at once and do all the transformations. But in this case, the map function is lazy, so it won't do anything until you don't pull out any value. So the execution of the map is in this case deferred until you pull out values. And in this case, I pulled out 3 values and I get the transformed values, and we don't have a Stack Overflow. Speaking of Stack Overflow, if we do this, so I added this to array function here, which is also a new utility function, this code will blow up because you know, we have this while true in here, and if we try to transform this iterator to an array, JavaScript will fill up until it will get to a Stack Overflow. So maybe this is then a good opportunity to talk about the lazy versus eager discussion. And maybe this is not the perfect way to divide the functions, the new iterator functions, but at least to me, it helped me understand it a little bit better. So if we remember our new utility functions, I tried to categorize them into lazy and eager. And if it helps you more, you could also say producer, consumer. I don't know, like I tried to find a good word for that. But anyway, so on the left-hand side, we have our lazy functions, which we can chain as much as possible or as much as we want. And they won't do any execution, or they won't like pull out values. And on the right side, we have functions which collect all the things that are in iterators. So if we were to use any of the right-hand side functions, you have to be careful that your iterator is not in an endless loop or doesn't yield you endless values, because otherwise you will have a bad time.
Sorry, doesn't sum then also early bail out if you return a empty value?
That's actually a good question. I haven't looked into that.
Yeah, if you bails out, yeah, but I mean,
Yeah.
to say like.
Also, find is also
Well,
something
find
like
could
that.
also bail out,
Yeah,
If it just
yeah.
finds the value, it
Yes.
doesn't need to go on. Yeah.
I think you only have to be careful with that, because you could run into like
True.
endless
Yeah.
endless
But with
executions.
two array, you act.
Yeah. Yeah.
Goes
Do
forever.
they all produce iterators?
We will come to that, but it's a good question. Yeah.
Is some probabilistic, so that it says with such and such percentage chooses. This way it has
No,
also
some.
to
Nah.
pull everything.
We will go over the functions later, so I will tell you what each of them does. But it was a good question though. So if we go back to this example, right? I looked at the utility function and I was like, easy. I'm gonna just use take 5. No, I don't mean the boy band from 1997. I mean take 5. And this is a very nice utility function because we can just add it to our array of utility functions in the back, and suddenly we are fine again because we are telling JavaScript, hey, only take take 5 values from the sequence and then do the stuff. And even though I'm collecting all the values, JavaScript will terminate early because I just told it to take only 5 values. And this little function is one of the most powerful functions because I've looked into how to implement this without, like with generators, and we will get to that later. So speaking of new iterator functions, remember this one. When I told you, when I tried to use map and keys, it threw me an error. So with the new features now, this is fine. I don't get the error anymore. But we have another foot gun because map is lazy and map won't do anything yet. So even though you can write this code and it won't throw an error, you still have to collect it to some array or something because otherwise it won't do anything. But there was this question before, is there like a rule of thumb to distinguish like the lazy ones from the eager ones? And actually that's a good question. So if we look at the lazy ones, all of those give you back a new iterator object. So like all of these which defer execution, like take, drop, map, filter, and flat map, all of these return you a new iterator object, and you can chain as many helper functions as you want. So this tells you that this is lazy. So take we already discussed before. Take will let you define a number of elements that you will take out of the sequence. Drop is also useful in some cases because if you are, like, it's a very political topic if 0 is a natural number or not. And if you don't want 0 in your natural numbers, you could just call drop with 1 and then it drops the first number and then you have naturals without 0. So yeah, map is a transformer function. It actually works the same as array map, just with the iterators, and also it's lazy in this case. And then filter lets you filter out elements from the sequence. It actually also works like the array filter, but in a lazy way. And then flat map lets you merge other iterators into your iterator, which is sometimes really useful if you have different kinds of iterators which you want to merge into one. But it is basically also the same as in the array world. And then on the other side, on the eager side, so to speak, all of these do not return iterator objects. They return some types. So like reduce, you can reduce some sequence to, like, let's say you wanna reduce the natural numbers and add them up or something. So it would yield number. And then the same with sum and every. You can test if some element meets the predicate or every element meets the predicate. And as you said, I can't say with certainty, but I would assume so, that it will bail out early. The sum.
It does so with arrays. So
Yeah, yeah. And also like the two arrays, very obvious. For each is for side effects because it yields void. And then the find one is a little bit tricky because if the sequence is has an ending number of elements, it will give you back undefined if it doesn't find the value. But if it's an endless sequence, it will just try to find it forever. So yeah, that's something to keep in mind. So yeah, I basically went over all of these functions already, so we can kind of skip over this. So nice, but what can I actually do with that? And now is the time when I go back to something I showed in my previous generator talk, because I was very proud to show this function, because I was like, yeah, you can have, you know, a generator which is transforming your iterable, and you can do it on the fly, and it doesn't, you know, it doesn't do it eagerly, but it only transforms the value when you pull it out, right? And we have map for this now. So, but again, if I was to swap this with from the array to the naturals, which is an endless generating iterator, we are in danger land again, because if we want to collect this again, then we will run into problems. So I tried to implement the function in like the old way, which is take without the new feature, just to show you how much code we will save. So actually, this take function just takes an iterator and a limit, and it will give you back a generator. And it's basically a very easy for loop that is only looping until the limit, and it will always call iterator.next. If the next is done as true, it will just return, and otherwise it will yield the value. And if you want to use this to fix this code, you could just wrap it in yet another function to make this okay again. But if we now look at the new functionality, this is so much easier because you just call your naturals, then you map over it, you transform your stuff, and then you can take 5 and it's me gusta, right? This shows I'm just very old. Anyway, you can do very cool stuff with the new functions because, as I told you before, all of these you can, of course, chain. So if you're a purist and you say 0 is not a natural number, you can just drop that. And also we can only take even numbers, and then we map over them and take everything or multiply them by 2, and then we only take 5. And if we spread this, it will iterate over all of them and print it to the console. We get 4, 8, 12, which is nice. So
only take 5 and you wrote take 3. So
yeah, you spotted the error. Yeah, I swapped this out later, and very keen eye. Great. I have to fix this in the slides then. Thank you. So when I researched this, I was like, oh, this is so powerful. I want to use this for async stuff because my whole generator talk was about it's so awesome to use this with async stuff as well. So like combining generators with async stuff. But can I use this for async stuff too? Short answer is no, not yet. And I was very disappointed to find this out. But there is yet another TC39 proposal though, and turns out that the async stuff was with the sync stuff. It was the same proposal, but they decided to split it. And now we have this proposal, which is called Async Iterator Help Us, but that one is only on stage 2. And I hope it won't take another 9 years until we get this. So soon TM, right? Yeah. Cool. So because the last time somebody asked, do I regularly use generators at work now? Because I did the talk and now there's this new like fancy functions. The answer is still no. But for some instances, it's really useful. And also with the new iterator utility functions, I am gonna definitely play around more with iterators because it's super nice to just use it that way. And the question then is, do I regularly use iterators as work? We all do implicitly. So yeah, I told you now that you're maybe unknowingly use iterators a lot of time. So I hope I could broaden your JS horizons a bit today. And that's basically it from my side. If you want to have some resources on this talk, I have them all on my website, where there's also a GitHub repository where you can look at all the source code I used to put into this talk. That's basically it. Thank you for your attention.